Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithm series. This video is part 2 for topological sort generic implementation. In part 1 we had implemented graph and directed graph. In part 2 we are going to implement the topological sort. Now we want to create a directed graph, so we will create a helper for it. We will create an object of graph that will help us create a directed graph. So we will have an apply method here that will be of type v, which will get a value adjacency list, which will be basically a map of value, and sorry, it's going to be capital M, map of value and sequence of v, which will return a graph of type v, which will be nothing but a new directed graph of type of value adjacency list. Now we also want to create an empty graph. So how we are going to do it? Will be of type v, where there won't be any value, and it is going to return a graph of type v, which will be again a new directed graph with a value as empty map. Now we are going to implement logic for topological sort, so we need a helper method for this. Private def topological sort, and this will have the first element as a node. Node will be of type v, and we have DFS step. So this DFS step is basically a type of DFS step. So we will be using a DFS approach to solve this problem, and it will return a DFS step of type v. So we need to create this DFS step first. So what we are going to do is we are going to create an object to this class. So it will be object of directed graph. This will be case class DFS step of type v, which will have visited. So whenever we traverse, we are going to append to this, and this is going to be set of type v, which will be nothing but an empty value initially. So it is going to be set of type v and an empty value, and we have a sorted value, that is sequence of type v, that will be again an empty value, so we can mark it as nil. Now we need to import this so that it is visible in the scope. So now with this value is available, we are good to write our logic for DFS sort. So first thing is it is going to search DFS step dot visited contains node. If yes, then just DFS step. If not, then the actual magic happens. Pre-DFS. What is going to happen in pre-DFS? It is going to collect all the values. Yes, DFS step dot copy visited is equal to DFS dot visited, DFS step dot visited, and then we are going to append our node. Now keeping it as set will help to avoid any duplication. Well, post, or you can use simple sequence as well. There you might have to implement your own logic to remove the duplication. Now for each neighbor, for node we are going to execute it and going to append it to our DFS pre-DFS step, and there will be a method that we are going to pass. Alright, we might not need to go that far, so this is going to be step comma n, and this is going to give us topological sort and comma step. So this is how we are creating the post-DFS. Finally, we are going to copy everything to sort. Post-DFS dot copy. Initially sort will be empty, and as and when we are going to hit the bottom, when there are no outgoing nodes, it's going to append. Okay, so post-DFS dot sort. So every time this happens, this is going to append the value. So how it is going to happen every time? So we have to call it here. So how we are going to call it here? Well, this is going to be this dot vertices dot. We are going to use fold left, and in fold left what we are going to pass is our DFS step of type v and an empty value, and again we have this. So first thing is that what we are going to get out of it is step comma n, and we are going to pass this to topological sort, and we are going to use n comma step, and ultimately what we need is the sorted values. So this is how we are going to implement. So as of now we are done with the implementation of topological sort. Let's quickly test it. G is equal to graph of int, and it is int with capital I empty dot add edges. So now we remember that we have this format, so we will be inserting values in this format. Okay, so now the value would be 0 comma 1, then add edges, then it will be 0 comma 2, then add edges, it will be 1 comma 3, again it add edges, 2 comma 3, then add edges, and this will be, we have 3 comma 4 and add edges, and 3 comma 5. So now we have the graph ready. Now we will be printing the value. Let's see how it works out. G dot whether we have got this topological sort or not. Fingers crossed, it's running, and you see, so the output is 0 1 2 3 4 5. So this is what we are expecting out of it. So 0 1 2 3 4 5. So this is the order in which it is going to do. It is going to do left precedence because we are using fold left. You can reverse it with fold right, and that you can do, and there could be further optimization like removing this set, rather than you can use sequence, but again that modification you need to do, and you can do that optimization on your own. Then you have to take care of inserting values. You should not insert any duplicates. And if you like this video, please subscribe and press on bell icon for further updates. Thank you.